All right, here's our video for 6.2a, domain and range of quadratics. Before we start the notes, I just kind of want to set you up for what we're going to be talking about. Um, then the last lesson we solved for quadratics. And remember that quadratics are something in this form, ax squared plus bx plus c. So when the highest exponent is a 2, we call that a quadratic. And a graph of this on an xy plane looks like a parabola. And this parabola has infinitely many points on it, okay? And each of those points has an ordered pair. The first one that we write is its x-coordinate, meaning what direction, left or right, from the origin do I have to go? And then the y-coordinate, how far, oh, hold on, let me re-say that. How far in the left and right direction and the up and down direction do I go to get this one point? Because that's an intersection of its horizontal and vertical counting pattern. And if I were to take all the x's from every point, just the x's, and put them in a set, that would be called the domain. And if I were to take all the y's from each of these points and put them in a set, we would call that the range. And in the past, we've done domains in inequality notation, something like this. But today we're going to rewrite it in interval notation. So it is a different set of symbols, but it describes the same information. So if I wanted to write this in interval notation, it would be -4, 3, where the 4 gets a bracket because it has an equal sign. The 3 gets a parenthesis, it has no equal sign. And this comma means everything between -4 and 3. So up here we had all the x's between -4 and 3, and here the comma represents that. And then oftentimes you'll see this out in the front. X is an element of, and then this is called, it's a range of values. It's also called an interval. So keep all that in mind while we do the notes. So that was your setup. All right, so on the notes, this is 6.2a, domain and range of quadratics. So we're going to start with a fill-in, and then we're going to talk about the symbols for interval notation. The set of all numbers between two endpoints is called an interval. The symbols we use to represent this set of numbers are called interval notation. And there's 4 parts to interval notation. At the front and back, you're going to have a parenthesis or a bracket. And then in the middle, you're going to have the endpoints of your interval, the beginning part or value of the interval, and then the ending value. And in this first spot, you're going to have either a bracket or a parenthesis. Same thing for this last spot, a parenthesis or a bracket. A bracket is for included values. So if you were doing interval notation, you gave a little equal bar under the less than or the greater than, that's an included value. It's like when we use closed circles on a number line, that's an included value. And a parenthesis is for excluded values. That's like when we used an open circle on a number line, or when you don't have the equal bar on the inequality. And then inside the parentheses or the brackets, we're going to have 2 numbers separated by a comma. These are the beginning and end points of our interval or range. The one on the left is always going to be the smallest value, and the one on the right is always going to be the biggest value. Right, and then we have a special circumstance for the value we call infinity. So infinity will always be written with parentheses, whether it's positive or negative. And that's because infinity goes on and on forever. You can never reach infinity. Therefore, you can never include infinity. So it'll never be included. It'll always be considered excluded. And we'll put a parenthesis on it. So what we have down here are some examples just for practicing the notations. Notice this is not an XY grid. There's no parabolas or quadratics here. It's just a regular number line left to right. And we're just using this to practice with the symbols. So for example, in this first one, my smallest value for my left boundary. So here's my left boundary and my right boundary. The smallest value is -3, so it goes to the left of the comma. And the biggest one is +3, goes to the right. And then they both already have brackets, so that's easy to know which symbol. And remember, brackets are just the same as if I had a closed circle here. It's just another way. Thank you. So I want you to pause your video and do 2, 3, and 4, and then we'll come back and talk about it. Okay, so hopefully you have these answers. Check your symbols with mine and make sure that they match. Notice we had one with infinity down here, and that one had a parenthesis for infinity. Okay, on the back. So we have a fill-in section up here. We just wrote interval notation for one number line. We will now explore interval notation for two number lines. One we know as the x-axis, and the other is the y-axis. Real quickly, let me just go back to the front here. So this was just one number line down here. A second number line, if we went through 0 here. So this would now be an x-axis and a y-axis, and we would be looking at left and right directions and then up and down directions this time. So this is what we're going to be talking about now. I'm just making up stuff. The domain is the set of all possible x values, while the range is the set of all possible y values for a graph. So we have an example here. I'm going to do one for you and then give you a minute to try the rest by yourself. So this example says, use interval notation to represent the domain and range of the quadratic graph. So here's our four-piece setup. We're going to have parentheses or brackets at the ends, and then we're going to have the lowest value of the domain here and the highest value of the domain here. And the domain is all the x values, meaning if you took every point that you could find on this graph and listed out the x's, that's your domain. So we want the smallest x value of any point on here and the largest one. Now, domains or x values, you're going left to right on the graph when you're looking for those, right? The x-axis moves left to right like this. When you go to do the range or the y value, so this is the x's, this is the y's, you're going up and down. You're scanning this way, up and down for the y values at each point. So let's do the x's first. So imagine you have all these points on this graph. The one that's farthest to the left is going to give you your smallest x value. Now it kind of feels like that's this point right here. But the reason why I'm not going to take that x value is because of this arrowhead. This means that the graph is going to keep going this way forever, up and to the left forever. So really there's no final point that's going to be all the way out to the left. So if the x's are going all the way out to the left forever, that's a negative infinity situation. So we're putting that to the left of our comma. And the same thing is true on the right. If you try to find the point that's the farthest to the right, you're never going to get there because this arrow means it keeps going forever. So all the x values of these points are going to go this way forever to positive infinity. And infinities always get parentheses, so the front and end is going to have parentheses. Now the range is the collection of all the y values of the points. So a second ago we were thinking left to right, but this time we have to start thinking up and down because the y values are on the y-axis, this thing. So if I look at the bottom to the top of the graph, so here's the lowest point on my graph. That is going to be the smallest y value of any of these points. And that y value is at 1, 2, -2 right here. Since that's the smallest y value, there's no other points below here. That's my smallest value. It's going to go to the left of the parenthesis. And then now I'm trying to find the highest point on this graph so I can find its y value. Kind of feels like it's here and here, but again, the arrows mean it's going up forever. So there's actually no highest point, which means the y's are getting bigger and bigger in this direction, which is positive infinity. So that's my upper boundary. And that always gets a parenthesis. And the -2 that's right here, that's a solid line. So if you think about that one point there, if you had a circle there, that would be a closed circle, not an open one. So therefore it's included and it gets a bracket. All right, so you pause your video and do 1, 2, and 3 down at the bottom, and then unpause and we'll come back and talk about it. All right, here are my answers. I want you to take a minute, pause, compare yours to mine, being sure that you're checking that the symbols match as well. The only special case that I want to talk about here on these problems is the range for this problem where the graph was opening down. So remember that the smallest value always goes on the left and the bigger one on the right. That's why negative infinity is here, because negative infinity is below 5. So that's your smallest value, so it goes on the left. And the reason why I bring this up is the most common mistake I'll see here is students writing this. Sometimes students get in the habit of just always putting an infinity on the right no matter what. But if it's negative infinity, it's going to be going on the left because it's smaller on the left and bigger on the right.